Okay, in this video, we're going to take the SuperCollider output data and we're going to attach it to our Wekinator process and start this machine learning task thing. So if you open Wekinator, you're going to get a window like this that pops up. And so I'm going to do my thing here. Okay, there we go. And so Wekinator is this free open source machine learning program. My other SuperCollider thing is running. It's sending data over here. So now we need to figure out how do we set up the machine learning that we want it to do. So you saw the 6448 number come up before. This is the default. Leave it as the default. We also saw the message label was wek/inputs in the previous file. That's cool. But we do need to change something here. So we're sending 13 numbers over. You saw that as one of the parameters in our code before. So we need to change that to 13. So this is saying I'm expecting, this message to come with 13 numbers associated with it. In terms of outputs, the code example I have is only going to have 3 outputs available. So you could change this though. You could add more outputs, and it basically just means that the next program, you're going to send a message out to the next program. It needs to know how many numbers to expect. I've only written code that it's looking for 3 numbers. If you want to have more, you can do that, but then you need to tell the next program, the processing program, that you should have more numbers that you're looking for. So change this one to 3. Leave all the other stuff the same. So wek outputs 12,000, that's the port number. So 13 and 3 is what we should be having. And when you click next, then you're going to get another window. Mine popped up on my other screen here, so I got to drag it over. And this is what it looks like. So you can see a whole bunch of interesting stuff here. We've got an OSC in symbol going green. This is green because we started our SuperCollider program and it is sending messages over. So because we're sending messages over, it's receiving messages. If this is yellow, it means you're not receiving anything. And so either your other one's not sending or it's not getting the messages that you need. We aren't outputting any messages right now because we haven't gone through the process of setting up and running it. But once we do, we'll start to see that this thing should also go green as well. Okay, so our input data isn't represented here other than that we're going to start recording input data and we know the input data is coming in. Our output data is actually represented though. And so we have 3 outputs here. Their values range from 0 to 1. You can see if you slide it around, there's 0 to 1. And these 3 outputs are going to be used to represent different sounds, basically. And so one paradigm you could think about is that if we have this one all the way up, 1, 0, 0, that could represent an individual sound, like ch. So if we have ch, that's 1, 0, 0. We could think then, similarly that we could define a second sound like this. So we could say 0, 1, 0. Let's say that one's like ch, ch, ch. Okay, put ch, ch. And then we can have a third sound that could be like zzz. Okay, so that's like 0, 1, 1 could be zzz. And then we can also think about the idea that maybe we want like nothing, because like it's a computer, so we have to tell it every single thing, right? So if we don't tell it everything, it doesn't know what to do. And so like silence, maybe we just want it to be 0, 0, 0. And so whenever there's silence, we want this thing to send out a message 0, 0, 0. So 0, 0, 0 is great. And again, if we go back and if we wanted to send out a 1, 0, 0 as a message, we could go shh, and then we could go and we could change all the things around. Okay, so that's the main idea. So we're going to input some data describing our sounds, and then we're going to output appropriate data that represents those sounds and identifies the sounds. So you could do 1, 0, 0. You could do like 1, 1, 0. You could do whatever you want. So it's up to you. But for like nice, simple, clean understanding of things, it's usually good to have very distinct states here, distinct representations like 1, 0, 0, 0. And you'll see why in a second once we get to actually starting recording and sending some of these messages. Okay, so that's it. We're set up. So if we want to record our first sound, I recommend that you use this paradigm that I'm talking about, which is this 1, 0, 0 thing. So let's put 1, 0, 0. That's our first thing. And then we're going to start recording. When we hit start recording, what it's doing is taking the information from our SuperCollider file that's sending over here. So it's not recording audio. What it's recording is those 13 numbers that we're sending each time that describes our sound. So every time those 13 numbers come in, they get recorded as data. That data then is used in our machine learning that will happen to classify and differentiate for these inputs, send these outputs. Okay, so let's make this a little bit more sensible here. So we're going to start recording. I'm going to record the sound first. Okay, so here we go. When you record, make sure you start making the sound before you press record, because you just want just the thing you're trying to identify, right? You don't want silence or something else to sneak into it. So I usually try to start the sound very clearly myself, and then I hit the record button. So and we can keep going. We can have like thousands and thousands of samples. I'm going to do 500 for each. We'll see how it goes. More samples generally are better, but there is sort of an upper limit that you don't really need to have 10,000 samples, for example. 1,000 is usually plenty. So I'm going to go to 500 for each one of these. We'll try it out here. And if it's not perfect, it's okay. Like the idea here is that we don't put in perfect data, but because we're going to try and find the commonalities and all that data, it's going to figure it out for us, which is kind of the beauty of this thing. Okay, so let's go to sound number 2. Sound number 1 is there. Here's sound number 2. It's going to be Okay, so here we go. That's great sound, by the way. Okay, here we go. Beautiful. Okay, and let's do sound number 3. Sound number 3 is going to be here, so 0, 1, 1. So whenever we do this sound, we want to send out a message 0, 0, 1. Okay? Okay, here we go. Sound number 3. Tick, 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 tick. What do I want to do? Okay, we're going to zzz. Okay, we're ready. Here we go. Beautiful. And I want one more output state. So my output state for this last one is going to be 0, 0, 0. And then hopefully this is going to be like silence. So when nothing's happening, all of them will just be 0. So if I don't hear anything, press 0. So I'm literally just going to not say anything, make any sounds, and just record the silence. There we go. So we have sort of 4 different sounds. We've got the sh, we've got the we've got the zzz sounds. There's 4 different sounds. So let's see how well it did. So the next thing we do is we hit this train button. Train is going to tell the algorithm, the machine learning thing, say, okay, figure out what combinations of inputs and outputs, how do they match up against each other. It's probably a terrible description of what's happening, but basically that is, it's going to figure out these types of input signals, we're going to match to this type of output signal, and vice versa. And this is using neural nets. And so basically what's actually happening is that there's a whole bunch of these like interconnections inside. There's little weightings and mathematical connections between them all, and we're going to figure out what all those weightings are. Okay, so let's train this thing. Train. It's training. It takes a little second to train it, so it's figuring it out. It's doing all the math. That one's trained. This one's trained. This one's trained. Beautiful. And let's hit run and see what happens. So when you hit run, what's going to happen is that we'll start sending out messages, which is good. So we're going to have all these messages we're going to send out. Great. And at the same time, we're going to be running the inputs, and hopefully when we make the sounds, you'll see that the sliders move in the ways that we want. So let's hit run and see what happens. Maybe it won't work. Who knows? Okay, so that's good. So like silence generally has them all sort of sitting down here. So let's go back to silence and me not talking. Great, they're all sitting down there. Okay, let's go with the noise. So with the noise, with pure noise, it's me just making that first sound. Hopefully this one's all the way up and it's mostly ones, and then these ones are down here as zeros. Okay, here we go. Shh. It worked, right? That was great. So we saw that basically this is like high up here as a 1, and then these were kept down as 0. So shh. Let's see if we can get the middle one. So it seems to work. And let's do our third one. It's perfect. It's like it's beautiful. So we're good. we have the machine learning running. We can identify different sounds. It's all wonderful. You have to think about the idea that it's trying to figure out the differences between things, right? And if you're really small differences, then it's going to be harder for it to figure out. So you saw that like my sounds are pretty different. They're quite different in terms of their frequency content and what they sound like. If you try to do sounds that are close, you'll probably need more data to actually be able to differentiate them, and it might not work that well either. So it's a tough thing. So finding appropriate sounds is a bit of a challenge, but at the same time, there's opportunity to improve that if you can tweak the algorithm and sort of tweak maybe the number of data bits you're putting in or whatever it is. But that's what hopefully something should happen. Like for you, you should be able to have, you know, the 4 different sounds, so 3 unique sounds, and then the 4th sound being silence. Basically having, you know, a big one there or a big one there, and then silence being all zeros. And if that works, then the next step is going to work, which is amazing. And so you need to run it. You can also save this. So if you go file save, it'll save all the weights and it'll save like all the learning that you've done, and it'll be able to respond to the sounds that you created. So that's it for this video. I'm going to pop over to the next video and connect this piece now, these outputs, this ability to differentiate sounds and send appropriate output signals output messages over to processing, which is then going to turn into an interesting visualization. Okay, see you in the next video.